Alright, so using what we've learned about energy in class, let's go over an example problem. So let's say we have a ramp of some kind. We don't really know what shape it is, but we know we have a ramp. And at the top, let's say we have a small marble. And what we want to figure out is how fast this thing's going when it reaches the bottom of the ramp. And so in physics terms, what we're looking for is the velocity of this marble when it hits the bottom. Oh, that was a terrible question mark. Alright, so we're looking for the velocity. And then let's say we know that the ramp is 10 meters high. Now, you may think that we need more information to solve this problem, but we actually don't. We can use the equations we learned in class about energy to figure this out. So, from conservation of energy, we know that the energy initial has to equal the energy final. That just comes from conservation laws in physics. And so, if we look at the energy initial, we know that the marble isn't moving at the beginning. It's just sitting at the top of the ramp, but does have some initial height, so it just has potential energy. Okay, and then at the end, it rolls down the ramp. It's moving as it comes off the ramp, but it doesn't have any height. So in that case, we have all kinetic energy. So the potential energy at the beginning has to equal the kinetic energy at the end. So using our equations, we know that potential energy is mgh, where m is the mass of the object, g is the gravitational constant, and h is the height. And we know that that equals 1/2 mv squared. Let me switch to my other writing tool really quick. Okay, so that equals 1/2 mv squared, where v is the velocity of the ball at the end. Now, if you notice, there's an m on both sides, so we can actually cancel those out. And then we can bring the 2 over to the other side. And what that leaves us with is that 2gh equals v squared. And so, if we square root both sides, then we're left with v equals the square root of 2gh. Alright, so now that we've solved for velocity, all we have to do is plug in our values. So we know that g equals 10 and h equals 10. So our final answer is that v equals the square root of 200. And that is in meters per second. Now you could either put square root 200 into your calculator or leave it like that. Both is fine. But that's our solution. The ball will be moving at square root of 200 meters per second when it gets at the bottom of the ramp. And there you go.